Okay, today we're going to derive the equations for a boost converter. Sorry, I can't spell. So, in a boost converter, it's very similar to a buck converter, although the difference is the placement of the MOSFET, diode, and inductor. So it's actually not very similar, but hang in there, stay with me. So right here, we have our boost converter topology. We have a load output, we have a diode, we have an inductance, we have a VN, we have a MOSFET. So now we could do our analysis. So like the buck converter, we're going to split our analysis into an off phase and an on phase. So during the on phase, what do we have? We have VN, we have the MOSFET on, we have VN essentially charging this inductor. So V out plus, okay, what's happening? Negative VN plus VL equals 0. So our volt-second balance equation becomes VL equals VN. Now in the off phase, this MOSFET is off. So then what do we have? We have VN right here. We have the inductor VL. The diode is on. We have the output right here across VO, which is the same across the capacitor. So we have minus VN plus VL plus V out equals 0. So we have VL is equal to VN minus V out. Okay, so in that instance, we can draw our duty cycle. This is the on, this is the off. We know that during the on phase, there is circulating current right here, pushing the inductor or charging the inductor up because current can't change in zero time because we know VL equals L di dt. Can't change in 0 time. So this slope ends up being Vn, This slope ends up being Vn over L. Then we have the off phase. This slope ends up being Vn minus Vo over L. So then if we put it into equation form, we have d Vn over L plus d prime Vn minus V out over L equals 0. We could take out the L's. We can move this over. Sorry, we don't need this part. Oops. Oh, becoming a mess here. Oh, get away. Okay. So, we combine like terms here. We have we can actually move this over here. All right? If we recombine this, we have d plus d prime. What happens in this case? D prime is 1 minus d. Eliminates these. And then we have Vn equals d prime V out, which ends up being Vn over d prime equals V out. So this is the voltage conversion ratio for a boost converter.